Welcome to this tutorial of the wind-driven circulation of the ocean. To understand the global circulation of the ocean surface currents, we have to understand the global patterns of winds. In this tutorial, you will learn how to analyze global surface wind data, as well as plotting synoptic maps. With that, you will be able to understand better how the ocean circulation works and how it comes about. Let's start with the radiation budget of Earth to understand where the winds come from. You probably know that the equator is warmer than the poles. That means that the same unit area at the equator observes more radiation from the sun than at the pole because the Earth is tilted. That means there's a surplus, or there's more heating at the equators than at the poles. That's about 6 times more at the equator. There's, of course, long-wave radiation, so radiation of heat that goes to space that tries to balance this, but that's not enough. It results in a continuous warming of the equator, of the regions at the equator, and a continuous cooling of the poles. To balance that, the circulation of the atmosphere and ocean have to transport heat from the equator to the polar regions. And that is the main reason why we have the circulation in the atmosphere and the ocean at all, to transport this heat to the poles and warm them. You probably have heard about the 3-cell structure of the atmospheric circulation, with the Hadley cells around the equator between 0 and 30 degrees north and south, as well as the mid-latitude circulation, or the Faro cells, in between 30 and 60 degrees north or south. So there's one here, and there's one there. There's also a polar cell, which will be not part of this tutorial. The Hadley cell and the mid-latitude cell have the characteristic easterlies and westerlies, and they together build the forcing for the ocean current circulation. Now remember these two names here, the westerlies that go from west to east, and the easterlies going from east to west. And you can see them in the climatology of surface winds. And this plot you will reproduce in the tutorial, right? So you see the imprint of the Hadley cells around the tropics, marked by these black arrows, as well as the imprint of the Faro cells, or the mid-latitude cells, in all mid-latitude regions, especially in the southern hemisphere and in the northern hemisphere. And then if you look at this pattern, this is in the mid-latitudes, we also have all these synoptic storms and all this weather, which we know about from the weather forecast. These are low-pressure systems with their cold and warm fronts that in the climatology, or in the mean, lead to these westerly winds. But they're very variable, and you will see that in the tutorial as well. On the long run, or in long term, the wind patterns set up a circulation structure, the so-called subtropical gyres, which are marked by these black arrows here. And there's one gyre in each major ocean basin. And these gyres just come from the fact that we have westerlies and easterlies, and then you get this circular structure. I invite you to learn more about the Ekman transport, which you need to understand the gyre circulation, but this will be also part of the following tutorials. Have fun with the wind-driven circulation.